Second example, still in 6.2, right? Sine theta tan theta equals tan theta. A big temptation for you is going to be to go ahead and divide both sides by tangent theta, right? And then you would just get sine theta equals 1. It's very tempting to do that, but it's dangerous, okay? Because tangent theta could be 0, right? If theta is 0, then tangent theta is 0, and then dividing both sides by tangent theta is illegal, right? You can't divide both sides by 0. So one way that you could handle that is you could say, well, okay, so I'm going to look at cases. I'm going to look at case 1, right? Tangent theta is not 0. And then you can go ahead and divide both sides by 0 and get sine theta equals 1 and blah, blah, blah. And then you can say case 2, tangent theta does equal 0, right? And then you can solve for theta from there, right? So you can look at 2 cases. A better way to do the same thing, essentially the same thing, is to just move everything over to one side and then factor, okay? That's the more generalizable way to solve equations. That's the way that you solved polynomial equations back in college algebra, right, Math 35. So that's what we're gonna do here, okay? So we're gonna subtract the tangent theta over to the other side. We would get sine theta tangent theta minus tangent theta equals 0. And now we can factor out a tangent theta. Okay. Now we apply the zero product principle, right? We can say, well, if this times that equals 0, then one of these two things must equal 0, right? Or maybe both, right? So we would say, so tan theta equals 0, or sine theta minus 1 equals 0. And now you can see you have those same 2 cases that you would have gotten if you had done it case-wise. But this is a little bit more elegant. It's a little more generalizable. So we like doing it this way. Okay, so for tangent theta equals 0, that means that theta equals tangent inverse of 0 plus n pi. Okay, for sine theta, maybe I'll color code these to make it less confusing, right? So we also had sine theta minus 1 equals 0. That would mean that sine theta equals 1. That would mean that theta equals sine inverse of 1 plus 2n pi. Or theta equals pi minus sine inverse of 1 plus 2n pi. So we can take all of these down a step further. Tangent inverse of 0 is just 0, right? So this is 0 plus n pi. 0 plus n pi is, of course, just n pi. So one set of solutions is just every integer multiple of pi, right? Pi, 0, pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi. All of those are going to be solutions to the original equation. Over here, sine inverse of 1. Well, sine corresponds to your y values, right? So sine is going to be 1 at pi over 2, right? So that means theta here is pi over 2 plus 2n pi. So there's another set of solutions. Or theta could be pi minus pi over 2. Right, plus 2n pi. Well, pi is 2 pi over 2, right? 2 pi over 2 minus pi over 2 is just pi over 2. Isn't that interesting, right? You get exactly the same set of solutions on those two. So obviously you don't have to write it down twice. When you're giving your answer, you can just write it down once. Okay? But that's our solution set taken together. So all of the solutions, right? So all of the solutions to this equation would be n times pi. So numbers of the form n pi. And then numbers of the form pi over 2 plus 2n pi, right? where n is an integer. So that's all of our solutions. If you're just looking for the solutions that live in the interval from 0 to 2 pi, okay, well, so then we can say if I plug in 0 for n, that's a solution. If I plug in 1 for n, that's a solution. If I plug in 2 for n, I'm going to get all the way to 2 pi, and that's too far, right? We don't want to include 2 pi in our solution set. So these two solutions come from n pi. And then I do the same trick over here, right? So if I plug in 0 for n, I get pi over 2, right? That's going to be in the interval. If I plug in 1 for n, I'm going to get pi over 2 plus 2 pi. That's going to be bigger than 2 pi. So that's gone too far. Okay? So those would be the solutions that live in the interval from 0 to 2 pi. Okay? And of course, I'm working in radians on all of these problems. You could have exercises that ask you to work in degrees instead, but you do the same thing, right? The same kind of thing. Instead of saying 2n pi, you'd say 360 degrees times n, right? Or whatever. But 2 pi corresponds to 360 degrees and so forth. Okay, so that's that idea.